So hello guys, so you are group what? What is that group? What? So very nice that so many of you are here. Wonder why. So very nice seeing you. Hello after a while. And today's theme is craniocerebral trauma, and we're going to talk about some lesions of a bone, of a skull, and then lesions of the brain trauma. We're going to talk about that. So what is the flight plan? So first, we're going to talk about skull fractures, okay? So skull fractures. Just a comment what to do or when you see it. Then, and I'll change colors as well. Then we're going to talk about whether we could call it a diffuse brain lesions. Then rather focal brain lesions. I'm going to mention during all of these some clinical correlates to it. And what is big, and I'm going to again mention it during the time, I don't know when exactly, it's the cerebral perfusion pressure, that's a big thing. Okay, so CPP, and 6, I'm going to show you some simple CT scans, CAT scans. Anyways, so let's start. Okay, so if we have a cranial trauma or skull fracture, just a small comment. There is one unwritten rule in a way, and you can have a fractures of base, okay? And by the way, if it's a basal fracture of the base, so the bottom of the brain, you know how you can tell there's a fracture? There's something clinical you can... Raccoon eyes, you're right, yeah, raccoon eyes. I have to be smart on the record. Anyways, so it's raccoon, very good, raccoon eyes. So you got like we call it monocle over here, like monocle, you know, the monocle is are the glasses, old glasses when they were putting it like that. So if you have 2 of them, that's very suspicious. But there's one more important thing. There could be leakage of liquid from ears, for example, okay? And what does this tell you when there's a leakage? That the dura got torn, okay? I mean, if there is no dislocation or whatever, you cannot do much about it, so just wait before the dura glues itself, okay? By the way, there's some tests to know if it's liquor or not, you know? What you're testing, if you're taking a sample. Yeah, exactly. But that's base, obviously, but then there is the upper part, so the cranium and the parietal bone and frontal bone and a temporal bone. And would you know a rule when there is a fracture, then, you know, you should decide. Now we're talking about skull fractures. So there's one rule where you should do a surgery or not. Very simple one. So I will just write it. So we talked about fracture of the base. So fracture of a base, and then fracture of the typically parietal bone, for example. So what do you think? Is there a rule? Fracture of a, e.g., parietal bone, which is common because it depends, you know, that's the upper part, so you hit yourself over here in these spaces typically. What could that be? That's a dislocation of the bones, okay, of course. So if there is, you know, what do you call it when the bone is pushed inside towards the brain? It's the impressive fracture, okay? So in this case, impressions, we call it impressions, so impressive fracture. And there is one small rule you can remember, and it's the width of the bone. So if it's dislocated more than the size of the, I mean, if you cut the bone, then you should rather do a surgery and put the bones back, like, okay, yeah? And guess why this is? So if it would be like that, like this, you don't have to so much, but if it's more dislocated like that, then guess why? It's also cosmetics, you can see it, you know, then you will see it on the, typically if there is someone after brain surgery and they were taking out the bone, of course, and putting it back. And if they don't like align it well, you can see it on the skull, under the skin. Yeah. So, but what do you think? Is there some risk of something? That's important. Could this dislocation cause something in future? Maybe. It of course depends how much space you have below the skull. But any ideas?
Increase the pressure?
Well, not so much. No.
Maybe entrance for infections?
Depends, of course. Depends, but rather not, I think. But depends. Depends. But of course, theoretically, why not? But there's one thing we're talking about, like now mechanically about it more, right there. So there's a dislocation of a bone, and what's beneath that? So I will put a dura here, okay? Or maybe I should put dura in. I will put it in brown, and I will put brain in yellow. Okay? So what do you think?
Rupture. It goes against the
It doesn't have to be ruptured.
herniation of the brain?
No, it's just a small, let's say it's touching just a bit slightly.
Bleeding?
What?
Venous bleeding?
No, that would be serious already, and we're going to talk about it later, but now it's just slightly touching the brain.
Meningeal irritation?
Okay, well, meningeal, that's a good idea, but if it's touching the brain, it could irritate the brain, and when we're talking about irritation of a brain, yeah, okay. So watch out if there is you do a CT and you see, if it's an old person and like there's a small brain and lots of liquid around, and then fine. But if it seems like there is a contact, whether you do you not only from cosmetic side, but yeah, there's a risk of epilepsy. Very good. So epilepsy, watch out. And by the way, and this is in general, any type of trauma of a brain is a risk of epilepsy, especially those we're going to talk about. So if someone has anything we're going to talk about today, then in half year, for example, they can go through epileptogenesis and they can have epilepsy, okay? Or any surgery, again, any surgery of a brain can cause epilepsy later on.
Will it be epilepsy or just seizures?
No, it's a definition of, so watch out. Any of you can have a seizure, okay? If you just have ion disbalance, okay, or whatever, if you have hypoglycemia, all of us, we can have a seizure. This doesn't mean that we have epilepsy. Epilepsy means that you have spontaneous seizures when you rule out all the causes. Anyways, in this case, this would be spontaneous seizures later on, so really epilepsy.
But there is a cause.
What?
The fracture is a cause. The irritation of the brain.
Yeah?
This is the cause. No?
Well, no. If you leave it there, it irritates it, stimulates the cells over there all the time, and at the end, this leads to spontaneous seizures, okay? Yeah? So if it's one seizure because of a contact and you put the brain back, fine, you don't have epilepsy, okay? But even though it's mechanical, okay, on epilepsy, you look at something happen, you can have it, you can have it inherited if you have a mutation of a channel, and you're going to have, like, since childhood, epilepsy, okay? But with this, it's like after trauma, whatever, then it happens that the cells are changing a bit, and you call it a process of epileptogenesis, and it takes a while. It takes months, years, but at the end, if you have a focus there, which spontaneously like starts the seizures, then you have epilepsy, okay? Like many of you, if you like, I don't know, don't sleep the whole night, you're partying, whatever, taking to it, you can have a seizure, but this doesn't mean you have epilepsy, okay? Yeah? You have to have these seizures without anything taking, okay? And being like, let's say, totally healthy in other parts, but you have spontaneous seizures, then you have epilepsy, okay? Anyways, and this could be one of the causes, mechanical irritation. That's why you put it back. So fractures, very simple. You just look. If there is an impression, you have to put it back. Otherwise, you leave it. So those are skull fractures. And now let's get to trauma of the brain, okay, or brain trauma. So, thanks for watching. And don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.